Hello everyone, this is DSA Zindabad. Today we are going to solve the 11th question of our Goyal DSA sheet, and the question is find all duplicates in an array. Now let's look at the problem statement. Given an integer array nums of length n, where all the integers of nums are in the range 1 to n and each integer appears once or twice. You need to return an array of all the integers that appears twice. You must write an algorithm that runs in big O of n time and uses only constant extra space, right? Now let's look at the example. And let's say we have this example, which is 4, 3, 2, 7, 8, 2, 3, 1, right? So what is our main goal? We need to return an array where all of the integers appear twice, right? Appear twice. So from this array, we can directly check like 4 is not appearing twice, 3 is appearing twice, 1 over there and 1 over there. So we'll store 3 as the duplicate element, right? Now moving on to 2. 2 is our duplicate number, right? So we'll directly store 2. Now 7 is not our duplicate number, 8 appears only once. So we'll return this as our answer, right? So what is our main goal? We need to return an array of all the integers that appears twice, right? Now let's look at the second example also. Over there we have 1, 1, 2, and 1 is appearing twice. So we'll directly return 1 over there, right? When there is no element which is repeating, right? So we'll just return the array, return an empty array, right? So let's jump into the approach and try to figure out how we are going to solve this question, right? First of all, let's talk about the brute force approach. Whenever there is an array in the question and we need to solve with the help of like brute force approach, what comes in our mind? Like just traverse over the array by following some condition, right? Let's say this is our array. Let's take this example 4, 3, 2, 7. 4, 3, 2, 7 and 8, 2, 3, 1 and 8, 2, 3, 1. So what does the brute force approach says? If we are present on this element, for this element, what we are going to do, we'll traverse over the entire array and try to find out whether 4 is appearing in the remaining array or not. If it is appearing, then we'll directly add in a vector or array, right? Moving on to 3, same process will be followed for 3, same process will be followed for 2, and so on, right? So this will require 2 for loop, right? So ultimately, which gives us the time complexity of big O of n square, right? And since we are not using any extra space, so it will require big O of 1 space complexity, and this is our time complexity, right? Now let's try to reduce its time complexity. Now let's try to figure out the better approach. Better approach. So whenever we need to find the duplicate in an array, what we need to do, like just think about some sort of like data structure which can store the frequency of each and every element, or right. So what comes in our mind? Hash set, and hash set store unique numbers, right? So how we are going to use hash set in our problem? Now let's discuss this thing. Let's say this is our array, right? Which is 4, 3, 2, 7, 8, 2, 3, 1, right? Now let's say we have our hash set as this, right? Now first of all, like whenever we are on the first element, since this element is the unique one, so it will directly go into our hash set, and there we will maintain our vector or array, right? We will store all the duplicate element, right? Since 4 is not present in the hash set, so it will directly go to our hash set. Moving on to 3. 3 is the unique element, so it will directly go into the hash set. 2, same goes for 2, same goes for 7, same goes for 8. When we move to 2, since 2 is already there in our hash map, so it will directly go to the our vector of array, right? Now moving on to 3, since 3 is already there, so it will directly go to the vector array, right? Now moving on to 1, since 1 is the unique element, so it will directly go to our hash set. Now we'll just need to return this as our answer, right? I hope like this approach is clear to all of you guys, like how we are going to use hash set to store all the unique numbers, and the numbers which are not unique, like what I mean, the duplicate number will directly go into a vector or array, right? Now let's try to discuss the time complexity and space complexity for this approach. Since we are just storing all the unique element in the hash set, so it will require big of n for traversing all over our complete array. Now space complexity will be big of n since we are storing all the unique elements in the hash set, right? So now let's, in the question, it is mentioned like we need to use constant extra space. Now let's try to optimize this better approach, right? Now let's discuss the optimal solution, right? Let's say in the question, just read the question again. Yeah. And in the question, just look at the constraints, right? These are the constraints, which says nums of I should lie between 1 and n, right? This third condition, right? Where n is the length of the array of vector, right? Now, let me write this thing down, which is nums dot size, right? Now let's take this example, which is 4, 3, 2, 7, 8, 2, 3, and 1, right? Now just look at this array. Just what is the length of this array? It is 8. Length is 8. Now all the elements which are present over there in the array, these all elements lie between 1 and 8, right? So now what we'll be doing, we'll just need to traverse over the array only once. So which will give us the time complexity of big of 1, right? So how we are going to traverse over the array? Now let's just discuss this thing. So for this, we need to keep this thing in our mind, like all the elements will lie between 1 and the length of the array, right? So from this, we can see that just try to observe the pattern in the array, right? Which is, this is our index 0, 1, 2, 3, 4, 5, 6, 7, right? So just look at this element 3 and this 3. Since 3 is a repeated number, so 3 can be treated as the index. 3 can be treated as index. Treated as index, right? And just so this will be pointing to the third element, which is 2. Initially, this will be pointing to this, and this 3 is also pointing to the third element because we treat each and every element as the index, right? Remember. So whenever we visit an element twice, this means we found our duplicate number. Now let's take the some different example. Let's take this, which is 2 over there. 2. Now treat 2 as the index. So this will be pointing to this element initially. Now when we traverse over the array and found the another 2, this will also be pointing to this because we treat each and every element as the index in the array, right? So we found that because we already found the 3 at the second position. So again, we are finding the 3. This means second is a duplicate number. Now just take the example of a non-duplicate number, which is 7 over there, right? Now 7 will be pointing to the 7th index, which is 7 minus 1 will be 6. So it will be pointing to this. Since there is no element which will also be pointing to the 6th index, so 7 is not a duplicate number. I hope this approach is clear to all of you guys, like how we are using each and every element as an index in our problem, right? This is the main condition why we are using it. So it is always like prefer like to just look at the constraint because some time constraint give us some sort of like hint to solve the problem, right? So let's do a dry run like for the same. just take this example again. So let's do a dry run for the same. Let's take this as our array or vector, and these are the indices, right? And this is our I pointer, this is our absolute of nums of I, and this is our index check, right? Initially, our pointer will be pointing to the start of the array, which is 4 over there. So absolute of nums of I will be equal to 4, and index to check will be equal to 4 minus 1 equal to 3. So what we'll be doing, we'll directly go to the index, which is there at the 4, and put a minus sign over there. So we'll directly put a minus sign over there, right? Now, after this, our pointer will be moved to this element, which is 1. Now, its absolute will be equal to 3. Now, 3 minus 1 will be equal to 2. So it will go to the second index, which is 2 over there, and put a minus sign over there, right? Now, after this, what we'll be doing, we'll directly go to the increment our pointer by 1. Now, this will be now, as you can see, like why we are taking as the absolute of nums of I, since we can encounter a negative element over there, right? Now, after this, what we are going to do, we'll just calculate the absolute of nums of I, which is minus 2. So it will directly give us the 2. So after this, 2 minus 1 equal to 1. We'll directly go to the element as at the index 1 and put a minus sign over there. So we'll put a minus sign over there, right? Now again, we'll increment our pointer. Now our pointer will be pointing to the 7. Now absolute of nums of I will be equal to 7. I hope all of you understand like why we are taking as the absolute of nums of I, because there might be some elements like when we put a minus sign over there, and this for the index to be positive, we just need to take the absolute, right? Now 7 minus 1 will be equal to 6. So we'll just go to the element at the sixth index and put a minus sign over there, right? Put a minus sign over there. Now again, increment our pointer. This will be pointing to 8. Now 8 minus 1 will be equal to 7. Now go to the seventh index and put a minus sign over there. Now again, increment our pointer. 5. Now 2. 2 minus 1 will be equal to 1. Now just go to the index or go to the element which is present over there at the index 1. Now go to the index 1. Now as we can see, minus sign is already there. This means 2 is the repeated number. This means this 2 is a repeated number, right? So what we'll be doing, we'll just add 2 in our answer. So after this, we'll just increment our pointer to minus 3. So this will be equal to absolute of nums of I will be equal to 3. 3 minus 1 equal to 2. So we'll go to the element at the second index. Now as we can see, there is already a minus sign over there. So this means this 3 is a duplicate number, because we already encountered a minus sign over there at the index 1, right? This is the main reason why we are getting this, right? Now we'll directly add 3 to our answer. Now moving on to, we'll increment the pointer to 1. Now we'll directly go to the element, like this will be equal to 1 minus 1 equal to 0, and there will be 1, right? Now we'll directly go to the index at 0 and put a minus sign out there. Now this, we traverse or complete array and we find that 2 and 3 is our main answer, right? I hope this approach is clear to all of you guys, like how we are traversing over the array and why we are checking the conditions. Like this is our main condition, which is nums of size, right? This is our main condition. This gives us the intuition like why we need to take the absolute of nums of I and the index and how we are traversing over the array, right? Now let's try to code this thing up. So here we are. Initially, we'll be having a vector as our answer, right? And we'll run our loop from 0 till the length of the vector till we'll increment our pointer. Now in this, we need to check the index. This will be equal to absolute of nums of I minus 1, right? We treat each and every element as the index minus 1, right? Now, if nums of index is less than 0, this means we encountered a negative value. What do we need to do? We need to push back this in our answer index plus 1, right? And our nums of index will be equal to nums of index multiplied by minus 1, right? Now, after this, this one is for the else condition, right? This one. Now at the end of this follow, we need to return our answer. This runs perfectly fine. Now let's try to submit this code. Yeah, this code runs perfectly fine. Now let's discuss the time and space complexity for the same. So now since we are just traversing over the array, so it will give us a big O of n time complexity, right? And the space complexity will be big O of 1. This is for like storing the answer because we need to return this in the form of vector. So we do not take this as the space complexity to be like considered as a big O of n, right? So it will ultimately be big O of 1 because we need to return our answer in the form of vector. So no need to consider this as in the space complexity, right? So our space complexity will be big O of 1 and time complexity will be big O of n. I hope this approach is clear to all of you guys. Thank you so much for viewing the video till the end. Please like, share, subscribe, and comment if you have any doubt. Thank you so much.